Okay, so we're looking at ACT Aspire Exemplar items. There we go, ACT Aspire Exemplar items. First question here says, Juliana divided the part of a number line from 0 to 1 into sections of equal length. So if we look, she went 1, 2, 3, 4 different lengths. She put M on the number line as shown below. One of the circles is shaded to represent the fraction that is equal to the number represented by point M. So let's look at point M. Excuse me. 4 parts. It's on the third one. Okay. So this number would be 3/4. So then we go through and we look at each of these and we say, okay, what are they equivalent to? Well, on this one, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 parts. 8 of them are shaded, so that's 8/10, which is the same thing when we simplify as 3/5. Not, excuse me, stupid me. 4/5, not the same thing. Okay, then we look at this one. 1, 2, 3, 4, 5, 6, 7, 8. This has 2 8s, which is the same thing as 1/4. This one is not going to be my answer. Okay, if we look and we see we have this part, this part, and this part, there's thirds. Okay, so 1, 2, 3, 4, 5. This is 5/6 is what it is. It's not that one. That should be obvious to us. This one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 4 not shaded, so that's 6/10, also known as 3/5. And here, so none of those are equivalent, so it has to be this one, but we'll go ahead and look at it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 parts. 3 not shaded, 9 that are. 9/12 is the same thing as 3/4. Okay, so there is our answer. Now on this bottom question, it says explain what a line of symmetry is. A line of symmetry cuts an object, a drawing, a picture, whatever, in half. Okay, half means they're equal. 1/2 and 1/2. So is this dashed line not, why is this dashed line not a line of symmetry? Well, you can see I've already drawn a line of symmetry here, cutting the heart in half. This dashed line does not cut it in half. Okay, so my dashed line does not cut the object in half. Sorry for my bad penmanship. Okay, so on question 3. Liam is making chocolate chip cookies. The recipe, there we go. Liam is making chocolate chip cookies. The recipe calls for 1 cup of sugar for every 3 cups of flour. So 1 cup sugar for every 3 cups of flour. This is an S, not a 5. That's sugar. Liam only has 2 cups of flour. So how much sugar should he use? So it's going to be less than. So we take 1 cup of sugar over 3 cups of flour equals X, or whatever variable you want to put up there, 2 cups of flour. Cross multiply. 2 times 1 is 2. 3 times 1x is 1. And it ends up being 2/3 of a cup, okay, of sugar. Explain why this answer is correct. We use proportions and cross multiply. That's the only thing I can really say with it. Okay, so wow. That's either Nigel or Wiggle or something. Class picked 10 empty rain gauges, placed 10 empty rain gauges on the playground Monday morning. The line plot shows the number of inches of rainwater in each gauge after it rained Monday afternoon. Okay, so this one has 3/8 of an inch. These two have 1/2 of an inch. Realize these are all at eighths. This has 3 that were 5/8 of an inch. These 3 had 3/4 of an inch, and this one had 7/8 of an inch. So I went through and I changed each of them into equivalent numbers, and it wants to know the mean amount. It wants to know the mean amount. So there was one of these. So when you get equivalent, when you're adding fractions, to find the mean, you add them up and divide by how many there are. So to do this, there's one of these. So that's 1, 3. 1/2 and 4/8 are the same. There's two of those. So I doubled 4 and got 8. Had 3 5s. 3 5s is 15. This is 6 8s. 3 8 is 18. And this is 1 7. So I added 3 plus 8 plus 15 plus 18 plus 7. That is 51 eighths. That's 51 eighths. There are 6 and 3/8. But that doesn't matter. Let's leave it as this because these are fractions over here. Now notice these two are the same number, but it wants the mean, not the total. So I have to divide by 10, which is the same thing as multiplying by 1/10. 8 times 10 goes straight across when you're multiplying. 51 times 1 is 51. 8 times 10 is 80. And so my answer is C, 51 over 80. Hope that makes sense to you. Okay, so Ryan and Tomas walked to school and then to the park as described below. Ryan walked 2/3 of a mile from his home to meet Tomas at school, so that's 2/3 of a mile. Tomas walked 2.7 miles from his home to meet Ryan at school, that's 2.7. Once they were at school, they walked X miles to the park and then X miles back to school. And so here's our drawing. X miles this way. Obviously, this is the same thing. That's 2X is how far they walked there. The sum of the distance Ryan walked and the distance Tomas walked is at least 15 miles, but no more than 21 miles. One of the following of the graph is the possible values of X. Which one? So we set up this. Excuse me. We set up the inequalities. They walked more than 15, but less than 21. 2x plus 5 is what they walked. Here's my 2x, and 2.7 plus 2.3 is 5. So subtract 5 all the way across. I get 10 is less than 2x is less than 16. Then I divide by 2. Boy, this pollen's killing me. And I get 5 is less than x is less than 8. So 5 Oops, here's my answer. I don't know why I circled this one. That's funny. Answer on this one's B, 5 to 8. Wonder why none of the students noticed that I made that one wrong the other day. So that answer is B. Oh, no. This answer is C because it's less than. It's not equal to. This has a dot on 8. They did not walk 8. It has to be less than 8. And it has to be more than 5. So it is, but that dot right there, ladies and guys, I'm going to say that answer is B. I don't like, because I can't tell if those are solid circles. They should be empty circles. It should look like this. On my number line, 5, 6, 7, 8, 9. Those should be open circles because they did not walk those distances, and then we're going to fill in the distances in between. No, I'm wrong. It says at least and not more than. Nope, it is greater than or equal to. So the dots are filled in. So that answer is B. Wonder why no one corrected me on that. Anyway, let's move right along. So that's question 5. Let's find question 6. There we go. Okay, question 6. A store is having a sale on 3 different items. Each sign below shows the original price of an item and how to calculate the discount of them. Click and drag the signs below to place them in order from least to greatest with the amount of discount. We want the amount of discount from the least amount to the greatest amount of discount. Okay, so if we look at this, our $3.50 is our of this. Take 10% off and then take $1 off of that. So I take 10% of this is $2.50, and then another dollar makes that a negative $3.50. Okay, so the original price of this is $24. 10% off makes $2.40, and then 10% off of that. So I take $2.40 from 24, which makes that number then $21.60. And so then I take $2.16 from the $21.60, add it to the $2.40 I had to begin with. I get, for a negative $4.56. Okay, this is take $1.50 off, which makes this $28.50, and then 10% off that. Well, 10% of $28.50 is $2.85, plus $1.50 makes $4.35. So from least to greatest, this was the least amount of discount, this was the next, and then this was the greatest amount of discount. Okay, so A was the least, C was the next the least, and then this was the most. Okay, so the function machine below takes an input value, X, and processes the value according to the processing equation inside the function machine and creates an output value, Y. From the numbers provided below the function machine, drag an input value to box X and the correct value to box Y. Okay, so we've got a couple of choices here. We've got all these numbers, but if I look at, now put a 0 in here, put 0 there. I get 0 squared plus 3 times 0 is 0 minus 2. 0 plus 0 minus 2 is a negative 2. Negative 2 is not a choice, so 0 is not a choice. I plug in 1. 1 squared, which I did over here, I find f of 1. Substituting in the value, f of 1 is 1 plus 3 minus 2 is 2, which is a choice here. So there's, I could drag 1 there and 2 there. Now I could also drag in 2. If I put 2 there, I substitute it in. 2 squared is 4. 3 times 2 is 6. That makes 10. 10 minus 2 is 8. So these two would also work. I could drag this here, and I could drag that there. 7 does not work. That's 49 plus 21 minus 2. There's not a sum there. 8 is obviously not going to, that's 8, 7, 8, 9 give us too large of numbers. So the two that work are f of 1, which is 2, and f of 2, which is 8. So that has two possible answers. Okay, question 8. So Elaine's Grocery has a, there we go. Elaine's Grocery has a lunch counter where people can order 3 types of sandwiches: egg salad, chicken salad, or falafel. Sandwiches can be made with 2 types of bread, pita or baguette. Draw a tree diagram, create a tree diagram by dragging and dropping the sandwich choices into the empty boxes to show all the choices combinations for a sandwich from the lunch counter. Now, the very first output here has 3 different boxes. You couldn't put pita, baguette, and pita, so you have to, the only one that gives you 3 choices are the egg salad, the chicken, and the falafel. So that has to be dragged there. And then from there, you can choose, once you choose what type of sandwich, you choose whether you want a pita or a baguette. And baguette is a long little loaf. So here these results are, and there's our possible outcomes. Okay, so in the long run, there's 2 of these, 2 of these, 2 of these. So there's 6 different outcomes. In other words, we had 3 choices of filler, if you will, egg salad, chicken salad, or falafel, times the 2 types of bread, and there were 6 different total sandwiches. All right, let's look at question 9 now. Question 9. Of the square shown below, it says B and H and F and D are all midpoints, and AC, CE, EG, and AG of the line segments. It's a square, so all these sides are the same length. A student thinks that the area of DEF, shown shaded, is 1/4 the area of the square. Explain why the student is not correct. So what I did was simply I assigned values. Okay, it doesn't tell us any lengths. We could have used 2, we could have used 4, anything of that nature. Simple enough. So I said each of these sides are 1. If each of these sides are 1, then this little triangle right here, this shaded area, has lengths of 0.5 times 0.5. Well, the area of the square is 1. Agreed? 1 times 1 is 1 square unit. To find the area of a triangle, you go base times height, 0.5 times 0.5, divided by 2. Base times height divided by 2, or 1/2 base times height. So 0.5 times 0.5 is 0.25, divided by 2 is is a quotient of 0.125. That is not equal to 1/4. That's equivalent to 1/8. So that little part is 1/8 of the original number. Okay, so let's go here. Question 10. A pattern exists among the unit digits of the powers of 7, as shown below. What is the units digit of 7 to the 50th power? That's 7 to the 50. Don't want to scare any of you by saying 50. All right, so if we look at this, 7 to the 0 power is 1. I just ignore that one. That doesn't have anything to do with me because I want to look at the whole numbers. 7 to the first is 7, squared is 49, cubed is 343, 4 is 401. 5 has a 7. This had a 7. 6 has a 9. This one has a 9. Okay, it rotates every fourth number. It rotates every fourth number. So my exponent, if I can take it by 4, I take and divide 50 by 4. It goes into it 12 times with a remainder of 2. My remainder tells me which the next number of the cycle. So my exponent's 1, 2, 3, 4, 1, 2, 3, 4. I keep getting these numbers. My remainder's 2, so that means 9 is going to be in its place. So 9 is in the ones digits. All right, question 11 says explain why there are no solutions to the systems of the inequalities given below. So here's my first line segment. It's y is less than negative 1/2 x minus 3. So I start at negative 3. I go up 1 and over 2 to the left because it's negative, or I go down 1 and over 2 to the right, and there is this line segment. This goes here. This one obviously then is going to be that one. And it says less than, so I shade everything below it. It's dashed because it's just less than and not less than or equal to. Same breath, these two are parallel. Their slopes are the same. This is plus 2, my y-intercept. So I started at 2, went down 1 and over 2, or I went up and over 2, connected my points and drew my lines. There's no common area that is shaded. There's no common area that is shaded. All right, then on the last question, a student thinks that the sum of 4.3 and 8.4 is 12.7 because 4 plus 8 is 12, which is true. 3 plus 4, the decimals in the tens place is 7, so that's true. The student then adds 3.7 and 2.6, and they say 3.2 is 5, 7, 6 make 13 because 3 plus 2 is 5, 6, 7 is 13. What's the mistake there? Well, obviously, 3 and 6, if we do it this way, and we do it in the correct order, this is 13, but we carry that 1. So 3 plus 2 plus 1 makes this 6.3, not 5.13. Okay, and there's our first 12 questions. I hope that helped.